Today's video is on the properties of real numbers. We're going to go through a lot of the ones that you already know and a couple new ones. So the first one you probably already know is the commutative property of addition or multiplication. The main idea here is that the order of the values does not matter. A couple examples, you could say 2 plus 3 is the same thing as 3 plus 2. Another example, 5 times 6 is the same thing as 6 times 5. Moving the order does not affect the outcome in addition or subtraction problems. Next property is the associative property. What the associative property says is that the grouping of values does not matter, and that could be of addition or multiplication. For example, 1 plus 2 plus 3, but if you do 1 plus 2 first, that's going to be the same thing as 1 plus 2 plus 3, but if you did the 2 plus 3 first. The 1, 2, and the 3 have to be in the same order. You could do the same thing through multiplication. 1 times 2 times 3. If you do the 1 times 2 first, is the same thing than if you do the 2 times 3 first. That's associative property. Moving right along, the identity property of multiplication or addition. The idea of the identity property is that your number stays the same. For example, for addition, let's do 5 plus 0. It's going to stay the same as 5. Whereas multiplication, 5 times 1 will stay the same as 5. The inverse property, we're going to use opposites to cancel a value for the inverse property. The way you do that, for example, for addition, let's take 5 again, and we're going to add the opposite of 5, which is negative 5, to make 0. The inverse of multiplication, if we do 5 and we're going to times it by what's called the reciprocal. Reciprocal means flipped of the 5 to make 1. Those are examples of inverse properties of addition and multiplication. The property of 0, if you multiply by 0, it's always going to equal 0. This is a real easy property. 5 times 0 is going to make 0. Any number times 0 makes 0. The distributor property, we are going to multiply a value to an expression inside the parentheses. When we do distributive property, you only do it when you have a variable. So let's start out with 3 times, in parentheses, x minus 2. Using distribution, we're going to multiply the outside number to both of the inside numbers. 3 times x makes 3x, and then multiplying 3 times negative 2 makes negative 6. Be careful with the distribution property. You could also have a negative outside the parenthesis when you're distributing to the two numbers inside. That would make this a negative 3x, and that would make negative 3 times negative 2 a positive 6. Just something to look out for. The main idea for reflexive property is that the number stays the same. A couple examples of how this could be said is that 5 equals 5. A equals A. The same thing on the left will equal the same number on the right. You could say 1 plus 2 equals 1 plus 2. They are the same as each other. Symmetric property. That says if A equals B, then you can flip it around and say B will equal A. An example of this in terms of math, real easy. If 1 equals 2, or actually you have to say the words if and then. So let's start over. If 1 plus 2 equals 3, then you have to write the word then flipping the equation around, 3 equals 1 plus 2. So you need an equation, and you're going to write them on either sides of each other. You need the word if and then. Let's move to transitive. Transitive says, a little longer, if A is the same thing as B, and B is the same thing as C, then you can conclude A is the same thing as C. Let's write this in terms of math speaking. Let's start with if 2 plus 3 equals 5, so this is my A and this is my B, and now let's do B equals C, so 5 is my B, equals, I'm going to come up with a new C, let's say 5 equals 5 times 1, so this is my B again, and this is my new C. Then I can conclude I need A equaling C. So 2 plus 3 was my A, equaling my C, which was 5 times 1. It's my A, and this is my C. If 2 plus 3 equals 5, and 5 equals 5 times 1, then you can conclude 2 plus 3 equals 5 times 1. That is the transitive property. The topic we'll talk about with properties is something you haven't heard before called the closure property. A set is closed under an operation if the operation always produces an element of the same set. If an element outside the set is made, the operation is called not closed. Let's do some examples. That probably was a little bit confusing for you. Let's look at number 1. Integers are closed under multiplication. Let's think about what integers are first. Integers are the negative, 0, and positive counting numbers going in both directions. So for integers to be closed under multiplication, that means I can take any integer here and multiply it by any integer times any integer, and it's always going to make an integer. Can you think of any example where we take one of these integers and multiply it by another integer and it not make an integer? There is no example. So we say true that all integers are closed under multiplication. All integers multiplied by integers will make an integer. Let's look at number 2. Our natural numbers, which are 1, 2, 3, 4, ... are they closed under subtraction? Meaning that if I take any natural number and I subtract a natural number, it's always going to make a natural number. That is false. Try thinking of a counterexample. A counterexample you could thought of is, let's say, 1, which is natural number, minus 4. That equals negative 3, which is not a natural number. Infinite number of examples you could have thought of for the counterexample. Number 3, even numbers, 2, 4, 6, 8, ... they're closed under addition. Meaning if I take an even number and I add another even number, is it always going to be even? That is true. There is no counterexample for that. Number 4, irrational numbers are closed under division. Irrational numbers are like pi, numbers that go on and on forever with no repeating. I take an irrational number and I divide another irrational number. Is it always going to be irrational? Think about that for a second. It's actually false. There is a counterexample. My counterexample that I thought of, if you take pi and you divide that by pi again, that's going to make 1, which is not irrational. So irrational numbers are not closed under division. Let's do the last problem. Perfect squares are closed under subtraction. The perfect squares are, write them down, 1, 4, 9, 16, ... So if we take a perfect square, I'm going to write PS for perfect square and subtract another perfect square. Is that always going to be a perfect square? That is false. An easy counter example, perfect square of 9 minus the perfect square of 4 equals a non-perfect square of 5. Write down what questions you have in closure or properties, and see everybody next time.